Personal finance practice problem using OneNote. Savings account compounding with the future value calculation. Prepare to get financially fit by practicing personal finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side in the Practice Problems tab, down in the 1150 Savings Account Compounding Future Value tab. Also note, when using OneNote, look at the Immersive Reader tool. Our presentations will also be in the text area with the same name, same number, but with transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we got our information up top, the calculations on down below. We're going to be doing a future value calculation, and this is probably the most straightforward or the future value calculation that would come to most people's minds. In other words, if you were to ask most people familiar with future value type of calculations to give you an example problem to demonstrate one, this would probably be it. Meaning you have some initial investment. In this case, we're going to say it's in the savings account. We're going to have the interest rate at the 4%, and we're going to imagine that it's going to be compounding annually, and we're going to look at how much we would have at some future point in time, given that in that case, this time frame is going to be 8 years into the future. Now, we're going to be picking a savings account here, but any type of investment will have a similar kind of scenario. Note that the amount of increase will change, or the format of the increase. In other words, it might be interest with the savings account. And if you're talking about stocks or something like that, the value of the stocks might be going up. Or if it's a home or land or bonds, then you can have a similar kind of problem imagining what the increase will be. Now, in this case, we have a situation where we have one set amount at the beginning, and we're just compounding the interest, which is different than the other scenario for a future value calculation being, in which we will see in the future, we have multiple payments periodically, say yearly, in a standard set period, which would be an annuity type of calculation. So this is not an annuity, present value of one calculation. Let's first go through it with our table kind of format and do a running balance type of format. Really useful no matter what method we use to do this calculation, whether it be mathematical formula, Excel functions, tables. It's good to then use your running balance calculation because it'll give you a little bit more idea and context about what is actually happening. So we're going to build our table down here. This is a bit tedious to do by hand, but very easy to do in Excel. We do this problem in Excel if you want to practice your table creation, which I highly recommend doing. So we have the investment. We're going to be starting at the $5,000 on the right-hand side, and we're just going to be increasing that 4% each year, each period. It's going to be compounding as we do so. So we're simply going to be taking the $5,000, multiplying it times, what did I say percent-wise? 4% times the 0.04. That's going to give us our 200. We'll add that to the original 5,000. That'll give us 5,200. If we then want to get directly to that 5,200, it's similar to a tip type of calculation. If you're tipping like a taxi driver or something like that, or restaurant, it would be then you're taking the 4%, 0.04 plus 100%, or 1.04 or 104% times the 5,000. That also getting you to that 5,200. Once there, we now have a new starting point, which we're going to be compounding and multiplying times the 0.04 to give us the 208. Adding that then to the prior amount, 5,200, we're now at the 5,408. We could take that, multiply times 0.04. We would then get interest increasing as we go. The 216, adding that to the 5,408. Would then give us to the 5,624. So we could see the interest increasing as we go due to the compounding and the increase of the investment and the calculation based on that increase of the investment amount. Multiplying this times the 0.04 again. We get now the 225 about. Adding that then to the 5,624 is going to then give us the 5,849 about. Taking that times the 0.04. We then have the 234, adding that to the 5,849 about, gives us about 6,083. Then we're going to multiply that a couple more times, 0.04. That's going to give us then the 243, adding that then to the 6,083 is going to give us then the 6,327, 6 years out. Two more times, then we have to stop this because it'll be done at that point. So you got to enjoy the last two here. This is the last two we get to do. We got the 253. We're going to add that then to the 6327. That's going to give us our 6580. One more time, last round. 0.04 is going to give us the 263, and we're going to add that then to the 6580, which is going to give us about the 6843 about. So the ending point after 8 years, not having entered anything else, but just the compounding of the interest, takes us from the 5,000 to the 6,843. Then we'll do the same thing, but this time with an Excel function. We do this problem in Excel, so if you want to see it in Excel, then take a look at that as well. We're just going to be printing out the function here and see how the data input would look within it, financial calculator being similar. So we're going to say equals negative sign. You could put a negative sign in front of the present value over here, which might be the more proper way to do it. If you do not have any negative sign, the value will typically result in a negative number. The negative sign basically flipping it to a positive number. I prefer putting it in front of the future value in front of the F. We're going to say equals FV brackets. We're looking at the rate then, which we could type in there at 0.04, but instead we're using B3, which is referring to our data cell up top, which is the best way to do Excel, to refer back to a data set so that when we change the data set, we can run scenarios with it. Then we're going to say comma. We have the number of periods. The number of periods is going to be 8, which again, we could type in there, but we're going to be picking that up from the data set. We have the 8 over here. Then we have the payment as the next item, but this is not an annuity calculation, but future value of 1 calculation. Therefore, we're going to skip through the payment item by putting 2 commas and then get to the final argument, which is going to be the present value, which is the 5,000, which we could type in there, but we're going to put B1, which is referring to the cell in the table once again. That then will give us the 6842.85, which is similar to what we got up top, except we added the pennies on down below here. We could do that same calculation with the future value formula, which would be the future value equals the present value times 1 plus r to the n, simply solving for the future value, straightforward calculation. Present value, you could plug in here at the 5,000 times 1 plus the rate, which would be 4% or 0.04 to the power of n, which would be 8. We're going to take that and put it into a table format. Very good practice to practice visualizing tables, good practice to put them into Excel, good practice to think about how like a tax return kind of format might be set up, or financial statements typically using a similar format as well. That being, in this case, we're going to take the 2 primary components of our calculation, put them in the outer column of the table. Any added detail to the calculation, we will have a sub-calculation for it, such as the 1 plus r to the n, indicating that it is a sub-calculation with a colon and indentation and bringing it into the inner column. Let's take a look at it. We got the present value at the 5,000. We then have the 1 plus the rate to the n periods. That's this sub-calculation that we're then going to be putting and indicating a sub-calculation with a colon, and then the indentations. Then the end result will be pulled out into the outer column in a similar way as you might see in some financial statement formats. We then have 1 plus the rate. Now we're representing that 1 as 100% because you can represent it in decimal format as 1 or percent, 100% this time, plus the 4%. That would then give us our subtotal, which we're going to calculate down here as a subtotal, which would simply be the 1 plus the 0.04, which would be 1.04 or 104%. We're going to take that to the power of n, which is going to be the number of periods. So we got to make sure we have a calculator that can do that. This one can't. So I'm going to go scientific on it. Those scientists do calculations like that, I think. So let's pick up their calculator. And so we're going to say this is going to be 1.04. And then I'm going to go to the xy, which gives us the caret to the power of 8 power. And there we have it. So we got the 1.3685 and so on. Pulling that into the outside now. So we pulled this subcategory to the outside. Notice I didn't indent them. Oftentimes we would indent them as well. But we pulled that outside. And notice we're representing much of the decimals, but not all of the decimals. It's going to be a long decimal number here. And then we're going to take that amount. I'm going to take the full number here. So this is rounded down here. I got the full number or closer to it up top. And we will multiply that times the 5,000 in the outer column to give us the 6842.84 about. So, and they've rounded it to 85 about. So there that is. So we got the second calculation of it. Now let's do it again, noting here when we look at the tables that this number right here will basically be how the tables are derived, but the tables will be rounded to 4 digits, and in so doing, they will be a little less exact as we look at the table. So let's do that. We're going to go to the tables down below. Straightforward calculation. You just got to make sure you got the right tables. So remember, when you're looking at your tables down here, you're going to have 2 present value tables, typically 2 future value tables, and each of them have an annuity one and a non-annuity, or in other words, 1 present value annuity table, 1 present value non-annuity table, 1 future value annuity table, 1 future value non-annuity table. We here looking at the future value non-annuity table. And so we're going to take the 5,000 times the amount from the table, and that's going to be found at 4% and 8 years. We're in yearly percents and we're in yearly periods. So we got the 4%, 8 years is going to be down here's 1.3686. So 1.3686. And there we have it. So let's go ahead and multiply that one out. So we got the 5,000 times the 1.3686. So we got the 6843, and it's rounded exactly. It comes out there. Now again, notice this is rounded to 4 digits, which the real number is going to be much longer than that. And that results in a fairly small rounding difference, which probably would not make a difference in our decision-making process. But remember, if you're in a test situation or in a school setting and they want you to use a particular method, then they can use that rounding difference, although probably immaterial in actual real-life decision-making, to force you to use the tool that they want and be able to tell whether or not you do.